Hello, my lovely students. Now we are back for section 2.3. So we're going to look at the other guys. So this is going to be secant, cosecant, tangent, and cotangent. All right, so I had to dig around in this section, but there's two different ways the book defines these four functions. So the first one is the one that you need to be more familiar with. Tangent is sine over cosine. The secant is the reciprocal of cosine, and the cosecant is the reciprocal of sine. So it's really tempting to think cosine goes with cosecant, but it doesn't. So those guys are kind of backwards, but it takes some getting used to. Tangent and cotangent, though, do go together. So the reciprocal of tangent is the cotangent. Now down here, they've taken everything we have up here and just translated it to the y and the x's. In my brain, if you can remember this, you could generate this, especially with the way I constantly draw all those triangles. So, but for sure, you're going to need to be comfortable with these definitions for calculus, like deriving the derivative of tangent, secant, cosecant, all of these. You go back to these definitions once you know the derivatives of sine and cosine, and then you can find them. Now, you're welcome to use either way, but like I said, you need to know the first definitions for calculus, and we need to know the first definitions to work out the simple trigonometric proofs we're doing. I say simple because there are trigonometric proofs that are long and tedious and silly. And we may see some of those once we get some of the more weird formulas, but again, that'll be when we get the weird formulas. For right now, they'll be pretty simple. So now that we have these definitions, though, any triangle, I can go ahead and figure out all the other trig functions for any particular angle, but also all of the ones on the unit circle. All right, so here we have our point. And we're being asked to find all 6 trig functions. Now there's one of these on the writing assignment, and we just ask you this over and over again. You just need to get comfortable with all of the different trig functions. So looking at our image here, straight line, yay! So we go positive square root of 2 over 2 over, and negative square root of 2 over 2 down. And that gets us to our triangle. So with our angle here, the opposite side is our sine, the adjacent side is our cosine. So sine of t is the negative square root of 2 over 2. Cosine of t is positive square root of 2 over 2. Now from there, tangent is just the quotient of those two, sine over cosine. So we have the negative square root of 2 over 2 over the positive square root of 2 over 2. So numerically, like, these are the same except for that negative sign. So when I have a number divided by itself, it's 1. A negative number divided by the positive of the number gives us a negative 1. All right, now our secant and cosecant. So I'm going to write cosecant of t up here next to sine of t because it is 1 over sine of t. So this is 1 over the negative square root of 2 over 2. Which equals negative 2 over the square root of 2. And then we rationalize for no real reason besides that's what our mathematical forefathers of yore did. It made sense in slide rules. It doesn't make sense with handheld calculators, yet we do it. Does have the occasional use in working longer algebraic problems, though, so it's not totally wasted. It's just not near as important as some books make it seem. Now we're multiplying by the square root of 2 over 2, so it's a crazy form of 1. And we're choosing the square root of 2, so on the bottom, the square root of 2 times the square root of 2. When I multiply square roots, I multiply the insides. 2 times 2 is 4. Square root of 4 is 2. So the 2's cancel, and we're just left with the cosecant is the negative square root of 2. So I want you to notice the sign was negative, so the cosecant was negative. All right, now our secant, we've kind of done some of the heavy lifting already. It's going to be 1 over positive square root of 2 over 2, which will do everything we did on sine, except it won't be negative. So here we get just the square root of 2. And then the very last one, our cotangent, is 1 over the tangent. And 1 over negative 1 is negative 1. So it is possible for the tangent and the cotangent to be equal for a particular angle. All right. So that is taking a point on the unit circle and then generating all of this. There are a couple other ways to do it. We could have, like, instead of drawing that triangle, we could have made a different triangle to generate all of the functions from. It all works. All right, number 2 here, same thing again, find all 6 trig functions and they give us an angle when t is pi over 3. All right, so first thing is pi over 3, not 30, 60. So this is a 30, 60, 90 triangle. So across from the 60, you can notice that leg is longer than the leg of the triangle on the bottom across from the 30. So this distance is 1/2. This distance is square root of 3 over 2. And the hypotenuse in the unit circle is 1. So sine is opposite over hypotenuse, so sine is the square root of 3 over 2. Cosine is our horizontal 1/2. Now tangent is square root of 3 over 2 over 1/2. And if you have a calculator that will give you answers in terms of square roots, you can actually type these things in and it'll even do the rationalizing for you. So that's one of the reasons why I recommend one of those scientific calculators that's about 20 bucks, because if it'll do the square roots for you, that saves you a bunch of mental hassle. All right, so here, fraction divided by fraction is the top fraction multiplied by the reciprocal of the denominator, and the 2's cancel. And so our tangent here is just the square root of 3. All right, now our other three, remember, sine goes with cosecant, and cosine goes with secant, just to be weird. So this is going to be 1 over the sine. This is going to be 1 over the cosine. So the secant 1 over cosine is 1 over a half, which is 1 times 2 over 1 multiplied by the reciprocal. All right, so the secant there is just 2. Cool. Our cosecant is going to be 1 over the square root of 3 over 2. So the reciprocal of that is 2 over the square root of 3. And then we typically write our answers rationalized. So we're going to multiply by the square root of 3 over the square root of 3. Weird form of 1. The top will be 2 square roots of 3. The bottom, square root of 3 times square root of 3 is the square root of 9. Square root of 9 is 3. So we get 2 square roots of 3 over 3 versus 2 for the secant. And then last one is the cotangent. So 1 over tangent means this is 1 over the square root of 3. So again, then we rationalize that. The square root of 3 over 3. So there's all 6 trig functions. And that is just using our definitions that I happen to have memorized. Now, I did talk about this in section 2.2, but here it is again. This is just the short list of who's positive where. So everybody's positive in the first quadrant. Sine is positive in the second quadrant. Tangent is positive in the third quadrant, and cosine is positive in the fourth quadrant. So when we say these things are positive, it means the other ones are negative. All right, let's do this one and then we'll cut the video so it's not too long. So negative 2 pi over 3. So we need to find the reference angle and then generate all 6 trig functions. So negative 2 pi over 3 compared to pi over 2. So 2 pi over 3, we know that's like 2/3. That's bigger than 0.5, but it's less than 1. So in our drawing, this angle, it's negative, so we're going to measure it clockwise. We go down, and it's actually going to stop in quadrant 4. So we have negative 2 pi over 3 is that first part, and then we need a little bit more to get to a flat 180 degrees. So we're asking ourselves, the reference angle is negative 2 pi over 3 plus pi, which is 3 pi over 3, so we just get pi over 3. All right, so pi over 3 is that angle with the vertex of the angle on the origin. Remember, pi over 3 is 60. So that means the side opposite 60 is our long side. And then the part adjacent to our angle is our cosine. And that will be 1/2 with a hypotenuse of 1 again. All right, so I'm sorry about the yawning. I never manage to get enough sleep these days. So the sine of t is our y distance. Now look at where this triangle ended up. It's in quadrant 3. So that means this 1/2 is actually negative, and this squared 3 over 2 is actually negative. So our sine, opposite over hypotenuse, is negative square root of 3 over 2. The cosine is negative 1/2. It's our x distance and our y distance. Now tangent, negative square root of 3 over 2 minus 1/2, or sorry, divided by negative 1/2, which means we're going to change it to multiplying by the flip of the second fraction, keep change flip, times negative 2 over 1. The 2's cancel and the negatives cancel, so we get a positive square root of 3. When we think about all students take tangent is positive in the third quadrant, so this tracks. All right, let's get back to our cosecant and our secant. All right, well, since cosine's negative 1/2, one over the cosine is just the reciprocal, so that's going to be negative 2. Cosecant is 1 over sine. This one will be a little bit uglier. We got a little more work. So this is going to be equivalent to negative 2 over the square root of 3. And then again, we multiply by square root of 3 over square root of 3. So negative 2 square roots of 3 all over 3. And then finally, we finish it up with our cotangent, which is 1 over tangent, which is 1 over the positive square root of 3. We rationalize. We end up with the square root of 3 over 3. All right, so we did a whole bunch of find 6 trig functions. Find 6 trig, no really, 6 trig functions. Like I said though, you're gonna see it on the writing assignment, you're gonna see it all over the homework. So guess where else you might see it? And on that note, I'll see you in the next video.